Hello everybody, welcome back to From Rhythm to Algorithm. Today we'll be picking up our quest to derive a unique definition for sensorality, the desire for censorship or the ability to censor. If you're new to this channel or new to this video and you're saying, what is this? Again, I'm a mathematician, physicist. I've proven a bunch of things. I've written a thesis, and these videos explain my thesis. But these videos actually cover more topics than my actual thesis, but this is part of a long series. As you can tell, this is part, I think 87 maybe. So we're picking up where we left off. You can get insight out of these if you watch them out of order for sure, but we'll be discussing different aspects of language, but we've built up a lot of intuition and a lot of logic and a lot of empirical facts to get to this point. So if you're just watching this out of order, this may or may not be insightful to you, but if you have watched any of these, then we will be watching or discussing things specific to the different physics, mathematics, and linguistics, and specific for this episode, we will be discussing aspects of language and continuing on with our iteration function, which we've demonstrated is how language builds. So continuing on with just more aspects of that, and so if you're ever exposed to what I call the raw data, in the same way you use a computer and behind the scenes the programmers see all of the raw data of the programming languages, my raw derivations, when I'm just basically what I do logically is no different than what you did when you did peer review in high school. You said one to the left, you looked to the person to your left, and you had to grade their paper, and they graded yours. And basically, they just provided editing. So literally what I'm doing is logically editing physical theory, but it has to be physically correct, and it empirically and overwhelmingly and viscerally is. But it really isn't anything more or less than an extreme amount of logical substitution, and the same thing where you have A plus B equals C, and then B plus C equals D, and then you do different algebraic rearrangements to solve for different variables. That is literally all I'm doing, but in complete generality. And so when you see my raw data derivations, you'll see it changes multiple times. I'll say, the fundamental physics is this, the fundamental physics of this, the fundamental physics of this is this, and then just some statement. And so what a fundamental theorem is, in the same way, again, keep our logic pyramid in your head. A fundamental theorem is the most general logical statement I can make, or that can be made about any given subject. And so I've introduced what's called the fundamental theorem of linguistics. Google it, doesn't exist because I don't know what anybody else is doing in research. But it should be, again, profoundly empirically obvious. What is the fundamental theorem of linguistics? The fundamental theorem of linguistics asserts that language is a physical system. It converges to maximum efficiency. And so what does it produce? Minimalistic expressions. Again, those are all of your work slogans, any lingo, any acronym from any discipline, any differentiation, any specialty, all of your sets of lingos, all of your work specific, all of your hobby specific, all of your culture, religion, music group, anything like that, any of those type of interests, any of those differences, those are all of those lingo sets. Those are all minimalistic expressions to increase efficiency. So it should be extremely empirically, shouldn't have any sort of convincing that it's true. But a minimalistic expression cannot be reduced and retain the same empirical meaning. Right? Just take some examples of a word. Let's just say where we have one, too many, the word many, M-A-N-Y, right? So many means a lot, several, substantially more than two, many, several, a lot. But if you break that down, you take away the Y, take out the generality, it says man, just man, M-A-N, right? So again, we take away our generality, it's probably a connection you probably haven't thought of before. Many is a general form of man, in the same way any was a form of an, right? A-N-Y, A-N. But you can't, if you reduce a word by a letter or by a syllable and it changes meaning, then you've reduced a minimalistic expression past what it logically means. And so in the same way our universe builds intrinsic properties, language builds properties. And so that's what a minimalistic expression is. And that is what the fundamental, that's the most general thing you can say about language, is that it is axiomatically, it is converging to minimalistic expressions, and if you reduce something too far, it loses its empirical meaning. And so we can now ask a very broad historical question, right? Again, I'm talking not just me, not just you, not just physics today. I'm talking language in its historic entirety, right? And so now the resolution, we've talked a bunch about quantum mechanics, a bunch about general relativity, and then, the thing that everybody heard is string theory. So again, what string theory actually is just, again, a hodgepodge of mathematical equations, but in reality, a string is the only way to be one-dimensional, right? A vibrating string. And so again, when we physically think vibration, remove all mass, right? When we're talking about the very beginning of the universe, when I'm talking about the stabilizations of R0 to R1, R1 to R2, again, that's the Big Bang. You need the Big Bang. So we're talking like 10 to the minus 36 seconds after the stabilization of R1 is when R2 stabilized. And so you don't think of vibrating as like a standing wave or like vibration like your cell phone. It's just literally just vibration. There's nothing else I can say. But then energy, you have an energy density, which is light. Light is honestly the word that gives me the hardest with physical intuition. Working on that now. And again, it's just force, right? You just create a rock in a hard place. You take this pile of logic and put it against this pile of logic, and then something has to give at some point. And once you reach that, you can resolve that contradiction, that irony, that inconsistency, and then you can prove something new. If you do it with fundamental ontology, you will prove an axiom. And so when you form minimalistic expressions on a personal level, on a industry level, on a discipline level, on a school level, and again, we've talked about the variety of differentiation, right? All of the different words that start with different letters, the different alphabets themselves, Cyrillic or Roman or Thai or Malay or whatever other script, Hebrew, any all of these other different scripts, they're all convergent, right? How many syllables in a word? We've talked a lot about syllability, but a string is the only way you can be one-dimensional. And we've talked about ing, how that can be that it's the fundamental minimalistic syllable, ing, right? You have a word like string or ding or wing or thing, right? Thing is the most general word for an object. And so ing is the fundamental syllable that represents vibration, and string is the fundamental object. It is the most general, specific thing something could be. But now, again, at the beginning of the universe, you don't have a standing wave, you don't have anything vibrating, you don't have light yet, you don't have any energy, you just have vibration. And so it is just the remnant of the intuition of that is why we say vibration and why history. I wasn't around in the 70s, 80s, 90s. Right, I wasn't born until 93. So the reason string theory is, again, humanity forcing logic converging to this minimalistic expression. Which, so logically, it's correct as to why there's an explanation as to why they use string theory. Mathematically, I'm still not even sure what they're trying to. There's not enough structure to mean anything. But that is what the fundamental theorem of linguistics is. And so from that, what else can I just want you to have that overall, that is the big idea, the overarching idea, and that is the fundamental theorem. But continuing on with the suffix ing, what else can we say, what function does the suffix ing have in language? Well, first of all, one that is, again, continued to be taught directly, incorrectly, all over the world, is what the infinitive, when you learn a foreign language, again, I'm a native English speaker, but when you learn any language that has infinitive forms of verbs, which English does not, if you just have one infinitive verb, it will always translate it, right? In Spanish, comer. They'll say comer, to eat. No, es problema. Comer, eating. It just reads, literally translates to eating. They'll tell you not to translate literally, absolutely incorrect. But right, you would say ir comer, going to eat. That makes sense. But if you translated ir comer as to go to eat, that doesn't make any sense. You wouldn't say, hey Johnny, to go to eat. You would never say that in any context. But if you said ir comer, going to eat, hey Johnny, what are you doing? Ir comer, going to eat. And so the infinitive form is read if there is not a conjugated verb which indicates the subject. You're reading that as an ing. And so that is the biggest result. Hugely tremendous. Literally the fundamental thing, and people are like, I can't learn a foreign language. And it's like, the first thing they do is teach you the wrong translations. So that's good. Good job, school. Keep that up. Good stuff there. But what else does ing do? We've talked about the letter E at the end of a word providing generality, keeping those words logically open so you can build upon them. We have the general form of a solution. It is what it is. That is the structure of all logic. When you create an equation, the word is relates this side of the equation. It is what it is. And so that's a general form. We're working on proving our axiom sensorality by differentiating that. We've already proven the axiom speciality. I had already had so much physical intuition when I started doing this, I simply stated the axiom of the fundamental theorem of linguistics, which has never been articulated, which is extremely obvious and simple. Simply that the fact that there was no general predominant theory or established statement for linguistics, right? Like, nothing. Like, good job on that one, all of academia. But vibration is the linguistic root, like literally the word when I'm showing you the deconstruction and the iteration of these words, with vibration being a big facet of that, is because it's the physical root. So vibration is the linguistical root because it is the physical root. Showing our consistency, again, I just wrote out all of the forms of vibration I could think of. Vie, to like compete for, to bid for, I'm vying for position. Vibe, vibing, vibrant, vibrate, vibrancy, vibration, vibrating, vibrational, vibrationality. And then, again, I just wrote that out, trying to again play with syllability. You know, how many words of a given word family can I show relation to with how many syllables? Again, I don't really care about the numeric results. I mean, I do the proofs, I prove axioms, anything. I don't want to say lower, because to me there's no gradation in mathematics, but in terms of completeness and personal interest, no numeric result is really interesting to me. So if I'm not proving an axiom, I really don't care. So there's a lot of lower level results that would still be huge results that I just don't care about because I can intuit the logic. Again, the part of me being a savant is when I read a word, I get the entire logical backing. I mean, there's just no part of the logic. If somebody else has articulated the logic itself, there was zero resistance for me to understand it and integrate it into everything that I'm doing immediately. Because it's all connected and it's all the same thing. But we can have some sort of a general form now, right? With the two different suffixes, we have E, something that ends with the sound E, represented by the letter Y, typically, again, indicates generality, but you take any noun, like right now, just any noun, and put the letter Y at the end. And what type of word have you just formed? Well, you formed an adjective. Well, now, take that same noun and put the suffix ing at the end. And what did you do? You just created a verb. So noun plus E equals adjective, and noun plus ing equals verb. Don't know really what to do with that, but we have some sort of generalization, some sort of general form of some solution. So that's kind of cool. But words are generally relative. So when I do logical derivations, I'm connecting the general logic. So when I see general relativity, I don't, like Einstein's general relativity, I don't go and look at an equation or E equals mc squared or this or that. Again, the equations are the result of fundamental understanding intuition. But again, when do you really learn something? Is it when you write it down? Is it when you think of it the first time? Is it when you teach it to somebody else? Right, so the learning process never really stops. But it's that first, when you have, again, my formal thesis is 42 pages, but it's that one light bulb moment. It's when that intuition really clicks. That's when you learn something. The papers and the equations and the proofs, that result from that are really just after that fundamental intuitive realization, that light bulb moment where everything comes together. You just say, aha. But, so when I look at general relativity, I don't say, what does the equation say, what does history say? I just say, what logic is presented by the words general and by the words relativity. General relativity. And right, words are literally generally relative. They are defined by their relation to other words. In the same way, positions and velocities are relative in Einstein's relativity. That's because it's, you need 3 spheres to completely map the Earth, or a sphere, right? You need 3 words to create a unique definition. And so all of this stuff is holding completely consistent. I mean, it's already proven, because I've already done all of these things. I'm trying to re-explain it to you. Because for me to do a new axiom, it takes me about at least 3 to 4 years, and it's not like my rate of derivation is always continuous. It's like there's literally a physical limit to how much information I can synthesize, and I'm working at that limit without having to think about it since I've been born. And you can say whatever you want, but I know that. That's something that I know, because just when you operate like me, you know. But words themselves are generally relative. Their definitions, their meanings come from their relations to other words. So, just a logical point. But again, I have generality and the likeness function. Again, the more things are close, again, whether it starts with the same letter or more specific, more poignantly has the same syllables, or is built on the same underlying complete word, if it's built on another minimalistic expression. Obviously, they're more closely related logically. They mean closer to the same thing. So again, people like things that are like them. And that's why you say, I like that, because it is like you. It reminds you of yourself. And so we can make a very clear differentiation to our sensorality, right? Sensorality with a C is selfless. Sensorality with an S is selfish, meaning I have a self, I have a sense of identity. This pen right here, it doesn't have any consciousness, any sentience, so it can't process or have a sense of self. It is selfless. And so remember, you can find the episode, but it's one of the first 2 of the From Rhythm to Algorithm series. We differentiated selfish and selfish, and now we have paired them to the axiomatic word. So again, remember, I don't reread these things, I don't rewatch these things. All of this logic just cycles and iterates personally for me. And so I just lecture on them when these topics come up, and I'm actually doing the derivation. Because I'm always doing the background work, always. I mean, that's been a constant information flow since I've been forming memories.